Welcome to GFR's Chemistry channel. Today I am going to discuss some of the points related with our organic chemistry. In this area, number of questions were coming for our NEET and some other competitive exams. Therefore, listen well. It is a simple topic. Meaning, here I am going to discuss about nucleophilic substitution reaction. Nucleophilic substitution reaction. We know that nucleophilic substitution. What is the meaning of nucleophile? Nucleophile means maybe charged, means nucleus loving. What is the charge of nucleus? Charge of nucleus is positive. If anyone want to love nucleus, sure the coming compound should be a negatively charged. Otherwise, it may be neutral. It may be neutral with what they required there. Neutral with unpaired electron. Lone paired electrons. Okay, it may be a negatively charged. Otherwise, may be with lone paired electrons. That means, one example, if I take an NH2 here, there may be a charge. Okay, there may be a unpaired electrons. Unpaired electrons. Some of the compound has a charge. Then best example, fluorine F minus, Cl minus, Br minus, I minus, etc. Everywhere having charge. This compound has, otherwise this atom has charge. This ion has negatively charged. That negatively charged ion easily attract with the positively charged nucleus. Therefore, when a substitution occurred by the use of a nucleophile, that is called as nucleophilic substitution reaction. Simple. Okay. Here, the types are very important. Two types of nucleophilic substitution reaction. Number one, SN1 mechanism, otherwise SN1 reaction. Okay, that is called as unimolecular. Unimolecular. If a reaction is unimolecular, sure, their own order equal to what? Order equal to 1. And also otherwise its on molecularity equal to 1. What is the meaning of that? Okay, I will explain you with the detail. Concentrate very well. Okay, then some of the conditions are here. For SN1 mechanism, the compound should be optically active. Optically active should be required there. Example, Rx, that means alkyl halide. When an alkyl halide mix with nucleophile, on that time the product will be RNU are there. Okay, but this reaction will be a double step mechanism, otherwise it is a two-step mechanism. How it can be occurred? What is the meaning of these two steps? Two steps means here number one, first category, the formation of cation. Cation should be produced. Meaning, listen here, and I taken here Rx. First, this Rx will be converted to X, means halogen. Halogen acquire the negative charge, otherwise halogen may taken this one here, this bond here. Now the charge of halogen will be negative, then R will be positive plus X minus. Now the carbocation is produced. Formation of cation meaning what? That is a carbocation. A carbocation is produced. Now the charge of R is positive charge. Positively charged alkyl group are produced. That is a carbocation produced. This is the first step. Then second one, here one more thing. If this formation of carbocation is not much easy. This one should be occurred by the presence of protic polar solvent. Protic polar solvent. What is the meaning of that? Protic means when a compound donate H plus ion. Polar means acquired two charges, negative and positive charges. Best example, here when I take an H2O, HOH. H acquire partial positive charge, OH acquire partial negative charge. Now it is polar. Not only that, they are ready to donate H plus also. Therefore, if anyone donate H plus, now they are protic. Polar means acquired the charges. Positive, negative, partial charges should be acquired there. Clear all of you? The condition, listen very carefully. First condition, optically active. The process will be occurred in 2 steps. Formation of carbocation. Here, the process should be occurred by the presence of protic polar solvent. Protic polar solvent. First step over, formation of carbocation. Then, here the carbocation formation process, carbocation formation will be a rate determining step, RDS, rate determining step. You know, in your thermodynamics, you may read that rate determining step means which one? It will be given by the rate of a reaction. The proper idea about the rate of a reaction, the idea given by slow step. Slow step. Here we know R and X are thoroughly joined. We want to break that. If you want to cut that, sure, it will be difficult. Therefore, the breakage will be occur very slowly. Therefore, why? It is a rate determining step. Okay, the formation of carbocation is a rate determining step. Therefore, why? This order will be 1. That means the first step only, the rate determining step. Just listen here. Then our second step will be formation of product. Product will be produced. Means already I got one R plus there. Means a carbocation there. This carbocation mix with nucleophile. On that time, very fastly, one is positive, other is negative. Very fastly they will be joined and it will be converted to RNU. There the substitution will be occurred. Before that, starting to start our process, we were taken RX, alkyl halide. Now instead of that halogen, one nucleophile will be joined there. Clear all of you? Next listen here. Here, one more condition there. Some of the other conditions also I will explain. Then here the nucleophile will be weak nucleophile. In your NEET exam, question answering will be very easy. Just you can consider which of the following process will be occurred, SN1, SN2, E1, E2. First you look the nucleophile or electrophile. If it is nucleophile, then you want to check is it strong or weak. If the nucleophile is weak nucleophile, no doubt there is a chance to occur SN1 mechanism. SN1 process will be occurred there. Then there should required very good living group. Very good living group are required there. Meaning, example, Rx. X may be iodine are there. I minus greater than, Br minus greater than, Cl minus greater than, F minus. Maybe one example like this, Rf. I have Rf and also I have Ri. Which one? In these 2 cases, which one can be occurred the SN1 mechanism maximum speed? Which one? This one. Due to iodine bigger in size. Therefore, why Ri bond length will be maximum. Cleavage will be easy. We know that where the carbocation formation occurred fastly, their next formation of product will be occurred. Therefore, why first we want to check formation of carbocations where it is easy. We know that on that cases, we want to consider there the stability of carbocation also. Stability order, stability of carbocation. Tertiary greater than, secondary greater than, primary greater than CH3. Gone like that. In which case the SN1 mechanism will be occurred very fastly. No doubt tertiary case. Tertiary meaning CH3 carbon, here CH3, here CH3. Then here positive in charge. And here we may take on one nucleophile. Process will be occurred very fastly and the product will be CH3C, CH3, here CH3 and Nu will be joined there. Therefore, why? The tertiary, in the case of tertiary, SN1 mechanism is preferred. Okay, the order of, the stability order of carbocation equal to reactivity order in SN1 mechanism. Reactivity order in SN1 mechanism. Okay, both are similar. Don't forget that. Next point is very important. In SN1 mechanism, there is a possibility to produce racemic mixture. Racemic mixture. They are produced racemic mixture. How they produce racemic mixture? What is the meaning of racemic mixture? Racemic mixture means it is the combination of retention configuration and inversion configuration. Retention and inversion. What is the meaning of that? Just listen here. When I take a compound like this, CH3C here, CH3, one more CH3 here, here may be iodine. Okay, then it can be easily cleaved down, and here iodine negative in charge. Carbon here, CH3, here CH3, here CH3 will be produced. A positive charge carbocation plus I minus, best living group is I minus here. Okay, now a tertiary carbocation, it is a tertiary carbocation. Formation of tertiary carbocation will be occurred. Now I got a triangular planar structure. Don't forget, it is a triangular planar structure. What is the meaning of that? Take one sheet, one paper. In this paper, it is a paper. In this paper, I drawn here one. Here may be one. Then here, gone like that. We are able to draw like this. Okay, now a triangular structure will be arised here. Carbon, one CH3, second CH3, third CH3. A positive charge occurred here. CH3, CH3, here also CH3. Now I am able to draw like this. It is a triangular planar. In this case, in triangular planar, listen very carefully. In Rx form, iodine will be in right side. That means this side. Just you can assume in front side. Iodine will be maybe CH3, iodine may be here. When I remove that one, carbocation produced. Now the carbocation shape will be triangular planar. Now the coming nucleophile are able to attach in front side. I removed iodine from front side. Then similarly, nucleophile again attached on the same side. Okay, now the same presentation will be arised like this. CH3C, CH3, CH3, here nucleophile. This is a retention configuration. This one is taken as retention configuration. Now, like this, a triangular shape. In this triangular shape, if the nucleophile want to join here, backside, that also possible. That also possible means iodine are here. The iodine in right side. If I need, sure, nucleophile may attach in opposite side of this iodine. Then maybe like this. Here we may draw this one. See here nucleophile, carbon, CH3, CH3, CH3. Reason it is a triangular planar. Therefore, why nucleophile are attached with front side or otherwise maybe in back side. If it is in back side, it is a just opposite of this one. Here, just a copy of this one. Both are same. Just iodine replaced it. Instead of that, nucleophile will be attached here. Now here the nucleophile will be attached in back side. Then this one is an inversion configuration. This one is an inversion configuration. If you get the mixture of retention and inversion configuration, now this mixture is called as racemic mixture. Clear all of you? Tertiary carbocation are able to prepare racemic mixture. In SN1 mechanism, there is a chance, there is a possibility to create what? Racemic mixture. Don't forget that. It is a unimolecular, molecularity equal to 1 and order also equal to 1. Why order equal to 1? Nucleophile don't want to consider there. Reason, the reaction starting step is a rate determining step. In that rate determining step, just the cleavage of alkyl halide only. There is no need of nucleophile. Therefore, why? The reaction depends upon the concentration of that substrate. Substrate here, the substrate means Rx only. Therefore, why this process is a unimolecular order equal to 1, and they produced racemic mixture. Now you got what is the meaning of racemic mixture? It is the combination of inversion configuration and retention configuration. Why this? It is due to the carbocation, stability order of carbocation, tertiary greater than secondary greater than primary. Same order will be arised from SN1 mechanism also. Now clear all of you? If a question coming like this, which of the following will be occurred the SN1 mechanism maximum fastly? Just you consider only one thing. Is it tertiary? If any tertiary are there, tick that. If any secondary, there is no tertiary, only secondary are there, check that. That may be the answer there. Clear all of you? They are produced a triangular planar structure. Therefore, why the coming nucleophile may attach on front side, otherwise may be on back side. If it is on front side, sure, iodine will be removed, otherwise the leaving group will be removed on the same side only. That compound is taken as retention configuration. Otherwise, maybe in opposite side of iodine. On that time, that is called as retention configuration. Okay. Here, the combination of retention configuration and inversion configuration are possible. Next listen here. Then what is the order? Order of SN1. How can we write? Tertiary greater than, secondary greater than, primary greater than CH3. Important for your NEET and other competitive exam. Don't forget. Next, now we are going to discuss. Now we want to know with SN2 mechanism. SN2 here only given there. It is a bimolecular. It is a bimolecular mechanism. Now the molecularity, otherwise molecularity or its order equal to what? That is equal to 2. Reason, here we were taken Rx concentration and nucleophile concentration both. Rx1, nucleophile 1. Total concentration equal to what? 1 plus 1, that is equal to 2. Okay, it is a bimolecular and its molecularity equal to 2. Bimolecular means molecularity equal to 2. Order equal to 2. Reason, now here there is no formation of carbocation. But instead of that, there is a formation of transition state. Here a transition state is produced. Here the order also, I will explain you what is the transition state. Order, that is primary greater than, secondary greater than, tertiary. You may have the doubt why this like this. It is due to minimum steric hindrance. Steric hindrance should be minimum. In this case, steric hindrance should be minimum. Therefore, why? Primary greater than, secondary greater than, tertiary. Now, what is the order of SN2? That is primary, secondary, tertiary, gone like that. Max minimum, where the steric hindrance repulsive effect will be minimum, there should occur SN2 mechanism. Then, now here, what is the meaning of transition state? When I take a compound like this, here may be CH3, hydrogen, hydrogen, and here may be iodine. Now I added one nucleophile here. It is a primary structure. Then nucleophile here. On that time, here C, maybe hydrogen here. Here may be CH3, here may be hydrogen. Now the opposite side nucleophile will be attached. Here there is no possibility to make racemic mixture. Here only one configuration, inversion configuration. Inversion configuration. This process is called as Walden inversion. This process is called as Walden inversion. Here just opposite side, from where I removed the leaving group, just opposite side the nucleophile will be attached. Therefore, why here the maximum important is steric hindrance. Steric hindrance will be minimum. Then only the process will be occurred very fastly. Transition state will be produced. What is the meaning of transition state here? Here CH, then here CH3, then here hydrogen, here iodine are there. just with the dotted line which can be attached there, the dotted line, their nucleophile are attached, just attaching. Then very slowly this bond will be strengthened and this bond slowly cleave down. Finally, it will be separated. In this stage is called as transition state. There is a possibility to create a transition state. There in SN1 mechanism we choose an polar protic solvent. But here we were taken polar, but the compound should be aprotic solvent. Aprotic solvent. Aprotic solvent means it is polar, means partial negative and positive charge will be there. But they are not ready to donate H plus ion. They are not ready to donate H plus ion. What is the example there? We have a number of examples. CH3COCH3. What is that? CH3COCH3 acetone and THF. What is that? Tetrahydrofuran. Furan structure. Here this one will be furan. Instead of this two double bond we were added hydrogen. This one is called as THF. Then DMF. Dimethyl furan. These all are the example for what? These all are the example for polar aprotic solvent. That type of solvent should be required here. Then only the SN2 mechanism occur. In SN1 mechanism, polar protic solvent. SN2 mechanism, polar aprotic solvent. Aprotic solvent. Don't forget the order also. I am going to discuss some of the important questions. Simple related with the nucleophilic substitution process. Listen here. First one benzene ring. This benzene ring here, they given A. Here produced product will be NO2, nitrobenzene. Question, what is A? What is A? Options. Number 1, NO2. Second one, HNO2. Third one, HNO3. Fourth one, HNO3, H2SO4. Then what is this process? This is a simple one. You know, nitration process. Here the occurred process is nitration process. For nitration process, what is the reagents there? Supporting agents are there. HNO3 and what? H2SO4. Here may be doubt. In HNO3 and H2SO4, which one? Both are acid now. Sure, two acids does not be activate in a same reaction. Then one should be acid and other should be base. Which one is base? Which one is acid? Listen, just one thing. Simple one. We don't want to explain the mechanism also. Just listen here. Here in HNO3, here only the NO2 will be taken. When I taken NO2 out, what is remaining there? OH remains there. NO2 only taken, now HNO3. Clear? NO2 only required, NO2 only added here. Clear all of you? Then what I removed from there? OH. When a compound removed OH, what we call? That is a base. Now HNO3 is a base here. This one acts as an acid there. Don't forget. Okay, clear all of you. Then next maybe there what is the listen here, instead of this H2SO4, not only the H2SO4 there, then instead of that H2SO4, we are able to take HClO4, chlorate compound. Okay, HClO4, otherwise H2SbF5 also suitable there. In some of the entrance paper, I met this one, HNO3, H2SbF5. You can tick that. That is maximum possibility reactions are there. This process is called as nitration process. Okay, then next second question. Second one, which one doesn't give benzoic acid with KMNO4? Temperature also there. When I add the KMnO4, which of the following does not be produced benzoic acid? Listen here, options. First option, toluene, CH3, toluene. Second one, this compound. Third one, what is the name of this one? What we call? 2,2-dimethyl compound. Then here, C bond, here hydrogen. Then third one, here C H2COOH. Which one does not give benzoic acid? One condition there. Listen here. What is a condition? Here, benzene ring attached carbon should have at least one hydrogen atom. If benzene ring attached carbon have one hydrogen atom, sure they will be converted to benzoic acid with KMnO4. Listen here. Now here benzene ring attached carbon has 3. Therefore no doubt it will be easily converted to benzoic acid. In this case, CH3, CH3, CH3. Benzene ring attached carbon has, there is no hydrogen atom. Therefore, why? This one does not produce the benzoic acid with KMnO4. Now look here, one hydrogen here. Sure, there is a possibility. Here two are there. There is a possibility. Remaining you don't want to consider. Benzene ring attached carbon has hydrogen or not. If they have hydrogen, sure, they will be easily converted to benzoic acid, oic acid with oxidation, best oxidation. That means with the KMnO4. Clear all of you? Then third question. When I taken this compound here, Br, this Br mixed with the Mg ether by the presence of ether, A will be produced. This A will be mixed with DOD and B are produced. Question, what is B? Okay, which one is B? How can we explain that? Okay, listen very carefully. Here first of all, when an alkyl halide, otherwise aryl halide, any of the halide mixed with magnesium by the presence of ether, there is the formation of Grignard reagent. Here the product will be Grignard reagent. Reagent are produced. That means now this one here Br, it will be converted to MgBr. RMGX is called as Grignard reagent. Now A equal to what? A equal to benzene ring and MgBr. Now here when you add H2O, H2O will be break down as H plus and OH minus. Similarly, DOD will be converted to D plus and OD minus. Now listen very carefully. Grignard reagent breaking time, magnesium is a metal. Here only cleave. That means here cleaved benzene ring. There cleaved. That bond will be break down. When I draw like this MgBr, same. Here magnesium has positive in charge. That means this electron from here, the electron will be shifted towards the ring. Now this one has what charge there? Positive in charge. Now ring has what is the charge of ring here? Negative in charge. Okay, now the bonding will be varied. Don't bother about that. Just create that one only. Then R group will be cleaved down as in the form of negative. When in this Grignard reagent breaking time, R group has negative charge. MgX has positive charge. Now this D plus will be easily joined there. Then the product, what is the product there? Here D are produced. Instead of hydrogen, one D, deuterium will be attached there. That's all. Then what is the byproduct there? Here remaining OD, this MgBr. Mg has positive charge, OD has negative charge. Directly joined there. Clear all of you? Okay, then the next question. Fourth question. Which one does not give Friedel-Crafts reaction? Which one does not give Friedel-Crafts reaction? Option A, benzene. Option B, OCH3. Option C, aniline. Option D, NHCOCH3. Here, listen very carefully. Which one is the answer? First of all, we'll explain with the answer. That is NH2. How we get that one? Here we know that Friedel-Crafts reagent. That is what? Which one is Friedel-Crafts reagent? That will be AlCl3. Otherwise, FeCl3. Here I choose an AlCl3. AlCl3. When I drawn like this aluminium from 13th group element. 13th group outermost shell has totally 3 electrons. That 3 electrons I arranged here. That one will be attached with chlorine. Now on accordance with the octet rule. Aluminium attained only 8. 1, 2, 3, 4, 5, 6. Sorry, 6 only there. Aluminium required 8. Therefore, why there is a shortage of electron. If anyone have the shortage of electron, sure, they act as a Lewis acid. It is a Lewis acid. Now look here, NH2, nitrogen has lone paired electron. If anyone has extra electron, they act as a Lewis base. Now this Lewis acid and Lewis base will be mixed together. Mixing not a matter. But after the mixing, they were produced a precipitate. That precipitate should be insoluble. Insoluble precipitate are produced there. If the insoluble precipitate are produced, the process blocked down. Process will be completed. No more reaction will be occurred there. Now we are unable to get the Friedel-Crafts process there. Reactant and substrate and reagent both are mixed together. And a complex intermediate complex compound insoluble precipitation will be occurred there. Therefore, why this is not a best method? Okay, now NH2 is not suitable there. Aniline is not suitable there. Clear all of you? Here there is a formation of precipitate. That precipitate will be insoluble. That is a problem. Insoluble precipitate formation. Maybe a doubt. Here also benzene attached with the NH. Remaining okay, no problem. Easily the process will be occurred there. Here oxygen are attached. No problem. Okay. In this case NHCOCH3. Then how can we explain that one? Listen here. Same Lewis acid, Lewis base, everything here also same. Here AlCl3, it is a Lewis acid. And this one, here lone paired electron are there, it is a Lewis base. Here also, this one Lewis base, this Lewis acid and base mixed together. Acid and base mixed together. Here also, what is produced? Here also, the formation of precipitate. But that precipitate will be soluble due to the presence of CO group. CO group are presented here, therefore why? It is soluble. If it is soluble, the further reaction will be occurred there. At a time, starting time, the precipitation will be occurred. But later, slowly, it will be converted to our Friedel-Crafts product. Okay. Therefore, why aniline does not react with does not activate in Friedel-Crafts reaction. It is due to the formation of insoluble precipitate. Okay, last question, fifth one. Which is least reactive for nucleophilic substitution. Maybe SN1, SN2, any of them. Not a matter. Which of the following does not be fastly act in substitution, nucleophilic substitution? Option A, CH3, CH2, CH2Br. Option B, CH2 double bond CHBr. Option C, C6H5. That means benzene ring. Benzene ring and CH2Br. Last option, bromobenzene. Which one and what is the reason? Here in SN1 mechanism, otherwise in substitution reaction, which one will be least? No doubt there, this one will be least. What is the reason? Steric hindrance. Steric hindrance, we want to require minimum, but here maximum. If the steric hindrance is maximum, the substitution reaction does not occur fastly, very slowly. Therefore, benzene ring, when a halogen directly attached with the benzene ring, there the substitution will be occur, but it will be slowly occurred. Okay, thank you for watching, and all of you just subscribe and make a bell icon. Then next video we are going to take on with the elimination, types of elimination, and also how it can be coming in our entrance exam. Okay, bye all of you.